Okay, so hi everyone, welcome back. Today we will talk about the most recently released model, Kimi K3. As the title states, Kimi K3 is an exceptional and excellent large model with around 2.8 trillion parameters and over 1 million token context window. And but I don't think this is not generally trained for everyone. So why? So over the next 20 minutes, I will explain why the Kimi K3 is not for everyone. I reviewed the recent NVIDIA GTC talk by the Moonshot AI CEO, Zhilin Yang, and combined with what's publicly reported about the Kimi K3 launch in the past few days. So what excited me most about this talk is the depth. And this is a CEO delivering a research level content, actual algorithms, loss curves, ablations. So I do believe that very few industry CEOs can go that deep. And because the core info that I took away is that the moonshot is not to just scale the parameters. They are re-engineering the fundamentals of how transformers and large language model are trained and structured. The design philosophy behind the Kimi K3 has a direct consequence. It produces a model that is really good at certain tasks, while making the deliberate trade-offs in the others. So as we go through today's talk, I will make it clear which results and innovations and scaling strategies come directly from Kimi's urban reports or projections, and which ones are supported by the independently verifiable evidence. Okay, so let's go. Here is our roadmap for the next 12 minutes. We will start with the single big idea behind the moonshot approach, and then we will walk through pillars of their scaling strategy and how they map into the actual model roadmap from the Kimi K2 to the Kimi K3. And also we will go one level deeper into each pillar, the Moon Clip Optimizer for token efficiency, and also the Kimi linear and attention residuals for the long context, and also the agent swarms for horizontal scaling, plus how visions fits in. Then we will land on the Kimi K3 itself. To be honest about these three limitations of the Kimi K3, I think that would be the reason for the statement of Kimi K3 is not for everyone. And I will close with some deeper insights. What this tells us about where frontier AI is heading, and concretely when you should reach for Kimi K3 versus when you shouldn't. And I think it's a through line in the box holds the whole talk together. This is a story about re-engineering fundamentals and how that produce a model that is powerful precisely because it is opinionated. All right, so let's start with one idea that organizes everything else. So the dominant recipe in the frontier AI has been scale, and more parameters you can see, and more data, and more GPUs, while keeping this kind of core machinery basically untouched. And Adam W as optimizer for attention, standard fixed register connections, and so on and so forth. So under that recipe, improvement tend to be additive. Moonshot is making a different bet. Instead of owning scaling, they go back and re-engineer the fundamentals. The optimizer, re-engineering the optimizer, and also they redesign the attention mechanism across both sequence and depth. And also they re-engineered how you orchestrate many agents. So the goal is to extract more intelligence per flops and per token, so that gains compound rather than simply add up. So not the line at the bottom is the money side in a sentence. Yang's point that the efficiency isn't just about efficiency. When training is cheaper, you can run more experiments, iterate faster, and afford architectural bets that a pure scaling labs simply cannot do that. Yeah, efficiency becomes, I think, is a strategic weapon, not just a cost line. So keep that in mind for everything that follows in the next slides. This is the backbone of the whole strategy of the scaling, three scaling dimensions, each attacking a different curve. So pillar one, token efficiency. Get more out of every token and every flop through a better optimizer and training stability. So for the pillar two is about the long context. So it is to make a million token context actually practical in memory, speed, and quality with efficient attention algorithm. So pillar three is about the agent swarms. It is scaled horizontally by orchestrating many more specialized sub-agent for complex and long horizon tasks. So the key word that Zhilin Yang use is resonance. This allowed us three separate features. You add together, they multiply in actually. So a more efficient optimizer lets you train a bigger and a longer context model, and long context windows makes agent far more capable and scalable. And also many more scalable sub-agent justify the training investment. So that's why I have joined them with some multiplication size. So the thesis is multiplicative gains in the intelligence, not the additive scale. So Kimi K3 is what you get when you push all three at once at scale. Here is how those pillars actually rolled out across the product timeline. K2, as you can see, pushed the Million Clip Foundation, a roughly 1 trillion parameter MOE model trained on the 15.5 trillion tokens with low loss specs. And that proves that the optimizer story at scale. And Kimi K2.5 added vision text joint training and the first version of the agent swarms. And the Kimi K2.6 and 2.7 generation scaled the swarm, pushed context longer and more matured Kimi linear attention. Now comes to the Kimi K3, reported to have launched around in the last week, I think, is for synthesis and roughly 2.8 trillion parameters of MOE structure that brings together Kimi data attention residual algorithm, and also stable latent MOE core architecture and 1 million token context window, as well as native vision training token input. So I want to be more clear is that the timeline and the K3 numbers are reported or projected from some public information, and the torque, the future data specifics, are not independently verifiable. So treat them as a directional, not as very ground truth recipes. The pattern is, I think that is a rare point from my point of view. I think each release added one pillar, and the Kimi K3 finally makes them resonate together. And let's go one level deeper. For pillar number one, the workhorse optimizer for a decade has been Adam or the Adam W. That's the most commonly used optimizer for the deep learning and the large models. But for Yang's point, for Zhilin's point, is that the 11-year-old optimizer is a bottleneck. We have simply stopped cautioning. right now, and the Moonshot answer is mu, which use the matrix personalized updates instead of the atoms per coordinate scaling. So the chart is the headline results on a log plot of loss versus compute, and the mu line sits below atom W everywhere for this kind of optimizer, and to hit the same loss, that is only about like half of the flops, roughly twice the token efficiency. Two crucial engineering additions made this work at scale. One is the weight decay becomes critical for large models, and then the second is the consistent node mean square updates, keep per parameter magnitude in the check. And to make it memory efficient, on the NVIDIA GPU cluster, they built a distributed muon that shared optimizer states across the data parallel group and gathers gradients just in time for the Newton sculpture iterations. The bottom line is that they doubled the value of every training token. And remember the earlier if you can remember from the earlier point that about the efficiency here, they also buys lots of the iteration speeds. So mu isn't free because although this slide is a nice example of the honesty in this talk, and when you scale mu up to like a mid-size training, you hit an instability because the maximum attention logic grows without bound. As you can see on the left plot, and the shooting past 1,000. That's what I can point out for you, and the run eventually diverged. So this is the kind of the failure that quietly kills large training parallel jobs. And for their solutions, Kimi K3 they fix this kind of instability in an elegant and surgical way, which they proposed QK clip. During the forward pass, and they already compute the max logic per attention head whenever it exceed a threshold time, and they simply rescaled that head query and key projection weights to pull it back down. And the mu plus the QK clip is what they call the mu clip. And on the right plot, you can see that the effect with the mu clip, the max logic right, the maximum logic rise very fast, and then get clips around like 100, and then actually it decays to about 30 as the training stabilized. So the payoff is on the banner. And the stable pre-training across the 15.5 training plus the tokens with zero loss spikes, and the reality on that scale is exactly what lets you spend your compute on the capabilities instead of babysitting some divergency. Pillar 2 is where the Moonshot gets generally inventive, long context. So full attention is quadratic, as we can know, right? And also the Kiwi catch becomes a practical war at the long context. And also that is a very hot topic in recent memory and optimization research. And the answer to solve this kind of issues is Kimi linear, which is built on the Kimi delta attention, or we can say it KDA, a linear attention mechanism that extends the gated data rule with smarter recurrent memory management and hardware layers. So clever, the design choice is that it is a hybrid approach, not just a simple wholesale replacement. They interleave linear KDA layers with full attention layers at roughly 3-to-1 ratio, and so you can keep the expressively of full attention where it matters well, capturing most of the efficiency. If you want to look at more details, you can look at the journal articles published or regarding the Kimi linear on the bottom right. So the two panels quantify the win, I think, and up to about like 75% less GB cache memory and up to 6.3 times faster decoding at a long 1 minute token context. But more critically, this isn't just a quality for speed trait. On their evaluations, we can say that the Kimi linear matches were beat full attention, and they also open sourced the kernel and the VMM integration, which is very important for some organizations. They want to deploy this kind of attention algorithm in their local and serve them in a very efficient way. So that is a more affordable way to deploy the long context algorithm and the model. So if you remember one technical idea from that GTC talk from the Zhilin, make it this one, the standard residual connections. The skip connections in every transformer and then add each layer output back with a fixed and uniform weight. So that assumption is about a decade old, and it has a really important cost. In every deep networks, not every single gets diluted. That's the key issues. And then a single narrow information highway will be, which is the singular dilution comes from. Attention residual rephrase this kind of problem beautifully from the Kimi's report, and the link builds on the IR stochastic linear line that LSTM is a wristlet rotated with 90 degrees. So residuals are essentially an LSTM unrolled over the depths. So that's a key inspiration from the IR's work. So the question becomes, what is the attention rotated 90 degree, right? So the answer is attention residual. Instead of fixed at each layer, use attentions softmax over the output of all previous layers, selectively retrieving the representation it actually leaves. You are applying attention across depths, not across the token sequence. So the benefits that we can get from the attention residual is that it actually mitigates the singular dilution, gives more uniform gradients and magnitude across the nano depths, and also it delivers about 25% higher training efficiency and 2% extra costs. So this is a very significant drop in replacement. As attention generalized, the on-end like the on-end and the attention residual generalize the residual connection. So that's the fundamental lot of cosmetic change from my point of view. Yeah. So pillar 3 turns a single model into a horizontal computer engine. So the idea is an orchestrator that dynamically spawns specialized sub-agents. So for example, we can consider the sub-agent as an AI researcher or a physical researcher or a fact checker or web developer or so on and so forth. So this decomposed a complex goal into many tasks, assign them in parallel, and aggregate the results across the multiple sub-agent. So this is scaled to hundreds of the sub-agent and thousands of tool calling. It can be ran in a concurrent way. They can read hundreds of sources in parallel and run many data analysis at once, and also write 100 pages reviews at the same time. So the training insight is that what makes it tractable, lively, and training a whole swarm end-to-end is a critical. It's a credit assignment nightmare. So when the final answer is good or bad, which of our 1,000 steps deserve this kind of rewards? The solution is a parallel agent RL, which is called like a PARL. And PARL, I think they trained the orchestrators while freezing the sub-agent. You optimize the one policy that does the decomposing and assigning, and then the set step, it blows it up. So this is how you get a reliable long horizon behavior, include the multi-step coding, deep research, complex agentic workflows, rather than just using a single model and only shines in a single turn. A quick but important detour on the multi-modality, because two of these findings are generally counterintuitive. First is that on how to fuse the version and the text tokens. Giving a fixed token budget, earlier fusion with a low vision to text ratio around 10 to 90 actually beats mixing a vision data than or more heavily. So less vision introduced earlier works better. Second, this is a striking one, I think. And adding visions does not just improve your image scales. It improves pure text reasoning. Actually, after vision reinforcement learning, the text benchmarks go up. MMU Pro, it goes by like a 1.7 point. GPQA Diamond benchmark goes up by 2.1, and the long bench V2 also rise up by 2.2. So learning to the reason over images seems to sharpen the reasoning in general. That's what they found. And also they found that starting from a minimum zero vision SFT and then doing vision reinforced learning outperforms a heavy text vision SFT on the vision and agentic tasks. For Kimi K3, the practical upshot is that the vision is kept in the loop for iteratively agentic work. So you can think an agent looking at the code and the screenshot of what the code produced and correct it itself. So multimodality here is a reasonably multiplier, not just built bought on. Now the payoff. Kimi K3, it is a synthesis of all three pillars. And though that the banner, everything on this slide is reported or projected. Kimi K3 reportedly launched around 1 week ago, with weights following be opened nearly around 27th of the July 2027, and the specifics are the future dated and unverified. So hold them loosely. That's my suggestion. But there's 4 things standing out that I can summarize. Firstly, the scale. A roughly 2.8 trillion parameters MOE with 16 of the 896 exports active per token, about 50 billion active parameters, which would make it the first open launched 3 trillion class model. Secondly, the architecture. It refutes everything we have discussed before regarding the hybrid linear KDA, attention residuals, a stable Latin MOE structure, and the native multi-modality of the Kimi K3. Number 3 is the efficiency, about 2.5 times better scaling than the K2 generation, and its quantization aware from the supervised fine-tuning onward, using the MX FP4 weights and MX floating point A activations, which is what makes a practical 1 million context with faster decoding realistically. And also, finally, the 4th point is regarding the capabilities. At launch in last week, it runs with always on maximum reasoning and targets long horizon coding, agentic task, and the terminal or software engineering benchmarks competitive with top closed models on things like the GPQA, terminal bench, this kind of benchmark performance testing. More crucially, I think it really follows Moonshot's openness company policy and the patent. They make the papers, canals, and hopefully next week the weights will also be open to the public. I think here is the part that the title promised from my today's talk. Why K3 is not for everyone, and to Moonshot's credit, they say this is themselves from the three limitations that I can refine from my experience and also what I can see. So first limitation, and it is very sensitive to thinking history. Kimi K3 was post-trained entirely with for reasoning history retention, so it depends on getting the complete COT, which is the chunk of sort back each turn. So if your agent framework drops the reasoning trees, or if you switch to K3 in the middle of a larger model session, you get context interference and also some unusable, unstable output because of the sensitivity to the history and memory loss. The mitigation is to use verified frameworks like the Kimi code and require your sub-agent to return the full syncing trees and to track the syncing history and avoid the switching models in the middle of the chat sessions. Secondly, the second drawback of the Kimi K3 is that it is overly proactive. Because reinforced learning rewarded long horizon hard tasks, Kimi K3 likes to push forward and make decisions for you. So that's an asset in a swan, but a liability when the user intent is ambitious or you want a cautious bounded assistant. The fix is explicit. I think is the behavior constraint that we can add to the Kimi K3 model. Especially, we can add the behavior constraints in your system prompt or the agent MD files. It is to tell that ask the AI agent before any major actions taken, and also make sure the human in the loop on the checkpoint on the very simple steps. Thirdly, I think honestly, there's also still a user experience gap versus the top closed model. And if you look at the Claude Fable 5 and the GPT 5.6 solely, and Kimi K3 still has some like a user experience gap when comparing with this kind of closed top models. Example like the consistency, Tom, multi-turn smoothly. The upside is that the open weight let the community fine-tuning for the UX and UI designs. That is the core advantages of the Kimi K3. And you can also use the hybrid loadings and a gender model for casual chat, and also you can use the K3 for the heavy syncing and lifting. And this are not bugs. They are just some kind of like the shadow side of the deliberate design and the training strategies and choice from the Kimi K3 that we can see. And then finally, let me wrap up today's video with some insights that I actually want you to take home. And I think the biggest one is that the limitations are not accident. They are because of the training and the design strategies and the choice. Kimi K3 was optimized to be a powerful and long horizon agent engine and not a to everything chat model. So once you see it that way, the proactive behavior and the syncing history dependency stop looking like a flaws and start looking like the costs of a very deliberate design and choice. So secondly, the Moonshot AI company is doing something real, and they are reconsidering the decade-old defaults. They are re-engineering the traditionally used optimizer, and also the redesigned the register connection and with full attention. I think most labs treat those as fixed and just scaled, which is not adaptive and dynamic for the future memory efficiency or hardware-aware large models or multimodality model design. Certainly, and the compilation of the efficiency first engineering with the open weight is generally different competitive posture from the pure scaling closed labs or closed source models. I think that's the reason why they can punch above their computer budget. All right, and finally, I think as a CEO, Zhilin Yang, who can deliver this level of technical depth, really tells you this is a research lead company and organization where they will consider the architectural bets as the first class strategy, not an afterthought. So practically, I also list a toolbox on the right, and you can see that the decision rules for each of the Kimi K3 on the long horizon coding research, agent swarms, parallel tools, and the meaning token analysis, right? And also we need to be cautious for high frequency simple chat consumer products that need a polishy or ambiguous intended tasks. Kimi K3 isn't just bigger, and I think it is more elegant and more efficient and more like a agent native multimodality AI model. So exciting time, I think, for open frontier models is coming right now, and most people think this is another DeepSync moment, and I believe so. And so I'm also very excited for the more and more fancy and capable and also efficient frontier models released to the public. So thank you. I think let's work, and feel free, let me know if you have any questions and put your comments in my video. Thank you.